Solve each problem, first write the inequality that matches the context, and solve the inequality to answer the question. Write out your answer in a complete sentence. Alright. Well, before we do this, just as a quick reminder, inequalities are such things as, this one's less than, because it's kind of shaped like an L, right? But then you have the greater than, which is like this one, because it's kind of shaped like that part of the G. You know what I'm saying? Right? But there are more. Another type of inequality is this equal to. It's just not equal to. In being not and equal being equal. So not equal is pretty straightforward there, hopefully. Alright, well there are others. There's this less than, but then it's got that line underneath it. That means that it's less than or equal to. The bottom part is just the bottom part of the equal sign, and the top part is that less than part. Right? But then we also have this greater than stuff, but also equal to. Now with the greater than or less than or equal to, it doesn't matter if it meets both of those conditions, because it necessarily can't. It just needs to be one of them, right? So for example, if we said that 6 is less than or equal to 7, some people say, well, that's false because 6 is not equal to 7. Well, it can't really be both. It just needs to be one. Okay? So it does satisfy that it is less than 7, which would make that true, even though it's not equal to. Again, it just needs to be one or the other. So number 1, you are going on a field trip and need to choose where to go. The Jew chart, that came out bad. Because I don't care if you're Jewish or not, you guys. Sorry. The zoo charges a $100 fee. Reading's hard too. Or a $100 fee plus $10 per student. The museum charge a $250 fee plus $5 per student. How many students need to go on the trip in order for the museum to be a better deal? Okay, well let's look at the expressions for both of these. First we have the zoo. I said it right that time. Which starts with a $100 fee. You're going to pay that up front. But then in addition to that, you're going to pay $10 for every student. So I'm going to put X there. You could put S for student, but S's kind of look like 5. So I'm going to say that X equals the number of students, right? So for example, at the zoo, if I took 0 students, how much would I be paying? $100, right? What if I took 1 student? $110. Very good, because you got the $10 now and then the $100. All right, well that's the zoo. Let's look at the museum. At the museum, we're going to pay $250 up front, but then in addition, we're going to pay $5 for every student. Which means that we're going to take that $5, multiply it by the number of students, and that will tell us the cost of just the students without the fee. So we need to add the fee onto that $250. It doesn't matter if you put 5x plus $250. I just wrote it in order because that's the way the words had it, and that's okay. All right, well then it says, how many students need to go on the trip in order for the museum to be a better deal? Meaning how many students need to go for the museum to be cheaper? Well, what we're going to need on this one is a nice inequality. So for example, we got the zoo, and we're going to compare it to the old museum, right? Museum. There we go. And what inequality would we use, Radicale? Yeah?
You would use 100. You would use.
All right, before we replace, though, what? I apologize. So.
You would use greater than.
Greater than? So it's going to be this way?
Yeah.
Is that right, you guys? Do we need the equal to part of that? No, we do not.
Because there's just a better deal.
Yes, that is very good. We want the better deal, which means that they can't be equal. All right? We did some of those last time, I think. Alright, and then what he was saying is now we're just going to replace the zoo and the museum with those expressions, right? So let's go ahead and do that. We're going to keep the greater than part of this, and then the zoo we'll replace with that expression. 100 plus 10x, and then the museum with its expression. Bam. There we go. Now we have a nice inequality to solve. Alright, with inequalities, as it turns out, we treat these the same exact way as we do equalities. It's just one minor difference, and we'll see if we can get that difference. In fact, I'll force it to happen. Alright? So some of you guys, for example, would put the x's on the left right account. In order to see this very unique case, I'm going to put the x's on the right. Okay. Well, what I'll do first is, I'll subtract my 10x from both sides, because I'm putting my x's on the right. And that would give me 250 minus a 5x. And this equals, we're going to drop that 100, and then it's greater than. And then I need to subtract my 250 radical, minus a 250 from both sides. And that would give me a negative 150 equals, now this is a negative 5x, because this term radical is a negative 5x. Keeps the sign immediately to its left, positive or negative. I put equals, I meant less than, of course. Well, right now, at this point, we're going to divide both sides by a negative 5. And this is the very unique case for inequalities. Okay? Is when we divide or multiply both sides by negatives, and this is only at this point pretty much that we do this, then we're going to flip the inequality. Okay, and that's again because we got those negatives right count. So we still got the x, because negative 5 divided by negative 5 is 1. But then we got negative 150 divided by negative 5. Bam, that's now a positive 30. And in context of this problem, we said that x was the number of students, meaning for the museum to be a better deal, you must take more than 30 students. So on this problem, notice we kind of solved this as though we're in equality, right? That's because right there at the end, 30 is less than x. That's because if we wanted to know where they were equal, that's where that would happen, at 30 students. Then the museum cost is the same as the zoo, which is again why we kind of treat it as an equality. So keep that in mind. It's important that we know that that is the breaking point for both of these. If we have less than 30 students, then which one's cheaper?
The museum. Wait, no. The zoo. Wait.
The zoo.
Yeah.
Yeah, the zoo is, right? If we take more than 30 students, though, again, that's where the difference, the change happens at 30. Now the museum is cheaper. One of the most common ways that teenagers start to make money is by selling candies. If you buy a case of candies, it can cost you about $26 for a box of 30-piece of big candy bars. I guess that's just big candy bars. Which means that if you sell each candy bar for $1, you get a $4 profit. If you and your friend Jay are both selling candy, we can represent this relationship by using and providing the distributive property. You and Jay sold a lot of candy bars. Let's say you sold 15 boxes in 1 week, and he sold X boxes. Not X boxes, okay? They're different. How many boxes does Jay have to sell if you want to make at least $180 together? So, let's go and write ourselves a nice inequality up in here. You have U, that's pretty good. And then we're going to add J, right? U plus J. And, it tells us that you want to make at least $180. So we're going to compare this to a good old 180 right here. And what inequality goes between these, though? Can you make equal to 180? And it be okay? Yes, because it's at least. So if you made 180 with J, you'd be very happy and could buy an Xbox, maybe. But this one's saying at least, so is it going to be eating towards the U and J or the 180? Well, if you wanted to make at least, that means that what you have between U and J needs to be much bigger than 180. Now, we should point this out as well. Okay, if we compared the 180 like these, and then you had U plus J, right here, it wouldn't matter if you wrote it this way. Okay. So depending on how you write it, it may look a little bit different, but it could also be the same. Again, depending on how you write it. So I'm just going to use this way because that's the way that we wrote it originally, though. Okay. Well, up yonder, it says if you and your friend Jay sell the candies. Let's see. If you and we can represent. And Jay sold. Let's say you sold 15 boxes, right? You're going to sell 15 boxes in 1 week. So for you, let's have you represent you because that's what we have. What would the expression look like, Radical? So we got to refer back to the problem, right? What it means, if you sell each candy bar, you get $4 profit for each box. Okay? So in other words, we're going to take the $4 and multiply it by the number of boxes, which was 15, right? So in other words, you collected in profit $60. Okay, so we can replace you with 60 bucks. Well, then it goes on to say that old J, so we'll replace J right here, but let's go ahead and figure out what his expression is. J sold X boxes, right? So he's going to sell X number of boxes, and how much money does he make per box? $4. So J represents 4 times X, or 4X. And we're going to add that to your 60 bucks. This needs to be greater than or equal to the 180. And they defined X for us, but we can still do that. X equals the number of boxes, if it helps us. Okay, so now we're just going to solve this. Once again, we will solve this just like we would a regular inequality. So we're going to subtract 60 from both sides, like at these, right account. And again, subtraction and addition do not affect the inequality. We'll drop this 4x. And 180 minus 60, bam, 120. Now, to solve this thing, we'll divide both sides by 4. Now, we're dividing by 4, right? Does that mean we need to flip the inequality? Yeah?
No, because it's not negative.
Correct! Very good. We're dividing by a positive, so everything stays the same. So x is greater than or equal to 120 divided by 4. Bam, 30. Now here's the thing though, is if you just write the inequality right account on a test or a quiz like we took today, you're going to lose points. So the answer to this one, since it's a word problem, right? Let's go back to the question. How many boxes does Jay have to sell if you want to make at least $180? You'd have to say that he had to sell at least 30. Again, that's where the problem is. We need to label that 30 box. Bam. So according to the directions, we'll solve each problem first. Write the inequality that matches the context, then solve the inequality to answer the question. Write out your answer in a complete sentence. Great. You are going on a field trip and need to choose where to go. The zoo charge $100 fee plus $10 per student. The museum charge $250 fee plus $5 per student. How many students need to go on the trip in order for the museum to be a better deal? All right. Well, here's what we know. We got 2 things going on up in here. We got the zoo, and then we've also got the museum.
Oh, I get it. Okay.
Like these. And then the zoo, it's a let's put this one in red. You got a $100 fee plus $10 for every student. So $100 is what you're going to pay up front. And then in addition to that, you're going to pay $10 for every student. So how do we represent that? Well, we're going to take $10 and multiply that by the number of students, which we're going to say is X. So X equals the number of student.
So you have a calculator. I can borrow.
You'll be fine. You won't need it.
I want it.
The museum, on the other hand, we'll do this one in Poiple. The museum charged $250 of fee, and then they'll add on another $5 for every student. So $5 times the number of students tells us how much it costs just for admission, and then if we add the fees, add the $250. Now, of course, we could use the commutative property if we really wanted to and make this 10x plus 100 or 5x plus 250, but we can keep them like this if we want. So, now we have this inequality. So inequalities we treat the same exact way as we would an equality. What this will tell us is where the two costs are equals. So when we solve this like inequality, it tells us how many students need to go on the field trip for the costs to be equals. So let's get that started up and count.
Wait, so we have to make
So here we go. All right, now, whenever we add or subtract on both sides, it will never, ever affect the inequality because we're treating it as an equality. It will only affect the inequality if we divide or multiply both sides of the equation, or inequation, by negatives. So just keep that in mind, all right? So here we go. I'm going to put all the x's on the left, which means I need to get rid of this 250 radical. So I'm going to subtract 250 from both sides, like these. And then I got a 5x is less than a negative 150 plus a good old 10x radical. And then I want these 10x's on the other side, so I'm going to subtract 10x from both sides, like these. Then I got negative 5x is less than negative 150 radical. And then to solve for x, I need to divide both sides by negative 5. Bam. X is compared to 30, but
31.
remember, yes.
I just figured that out.
That-
I didn't even pay attention. What the
Now,
heck?
well, hold on. Oh, yeah, but you should pay attention, by the way.
At the exact same time as you did.
That right there was a less than. But we divided both sides by that negative 5 right there, right? So what we're going to do is we're going to flip the inequality and make that x is greater than 30. What this means is that if you took 30 students on the field trip, the cost at the zoo would be the same as the cost at the museum.
Why did you start on the left?
There's no advantage.
Because you always start left to right.
Well, you can't have 0.1 students as much as we'd like that.
I
Now, at the same time, though, this is saying that x is greater than 30, and x represents the number of students, right? So if we have more than 30 students, suddenly the museum cost becomes less, which is what it would be considered, why it would be considered a better deal.
So it'd be greater than
So if we wanted to go on a field trip, we'd have to do math.
No, not greater than or equal to, just greater than. Once it's equal to, then it's not a better deal anymore. It doesn't matter which, it's the same deal, that's very good, but it's not a better deal.
So it has to be
Wait, so if you're deciding to go on a
So-
thing, you have
I
to do
figured
math.
that out. Right.
Well, yeah, you know, if you want to do it right, if you don't care how much you spend, then you don't really have to, I
Just
suppose.
drop money.
How do you do it?
But,
Oh.
notice in this, what this means also is that if you take 29 students, which is the cheaper deal?
A zoo.
The zoo.
Yeah.
The zoo. What if you took 15 students, which is the better deal? Zoo. What if you took 115 students?
Museum.
Museum. Bam, there you go. Good job. Now, how many students need to go on a trip in order for the museum to be a better deal? You have to be able to write this as a word problem, as words in a sentence. Okay. So you'd have to say something like at least. This would be the actual answer. At least 30 student.
Are you writing that?
I'm sorry.
At least 31, right?
Yeah, it's not at least. That's bad. More than. That's better. More than. See, then it's not equal to the 30. More than 30 student.
But look, it says x is greater than 30. You're just making stuff complicated.
Yeah. Can you
I'm sorry, what was that? Number 2, if there's no questions. And one of the most common ways that teenagers start to make monies is by selling some candies. If you buy a case of candies, it can cost you about $26 for a box of 30 candy bars. Which means that if you sell each candy bar for $1, you can get $4 profits.
Not very good.
If you and your friend Jay are both selling some candies, we can represent this relationship by using and proving the distributive property. You and Jay sold a lot of candy bars. That's nice.
I don't know who Jay is.
Jay's your friend, it says up there.
I don't have a Jay friend.
Well, it says it's your friend. Whatever the case, you and Jay sold a lot of candy bars. Let's say you sold 15 boxes in 1 week, and he sold X boxes. Not the game consoles, just that number of boxes. Okay. Be careful on that, because last thing I need to see on a test for this type of problem is, well, he sold X boxes, not candy bars. Okay, well, you still get a
So you need
0.
like hundreds of dollars, and Jay was still just like sitting there selling candy bars.
Yes, that's what you would say if you want a 0, okay? How many boxes does Jay have to sell in order for you to make at least $180?
That would take a lot of boxes.
Now, what? We'll see. So, you want to make $180 together. Does that mean it can be equal to $180? Yeah, because it's at least.
Yeah.
So if you made at least 180, you would be extremely happy, and maybe you'd go buy an Xbox. I don't know. All right.
They're kids.
All right, so here's what we know. We know you have you, and then in addition you have your buddy Jay right here. And then we got to make at least $180, right? So we're going to compare what you and Jay make. So you is the cost, or how much money you bring in profits.
Could your name just start
Jay.
with an O instead of a U?
Can your name start with sh? All right. And Jay is how much old Jay brings in. Well, since it's at least $180, it could be equal to 180. That'd be nice. But really what you guys want is to make more than $180. So we're going to make it eat you and Jay. We'll get to that eating stuff here in a moment. But right up here, it says you sold 15 boxes. They said cases, but they meant boxes up here. Okay? I guess these boxes, whatever. So you sold 15 boxes. That's how much you're going to sell, 15 boxes. And we know that each box, if you sell the whole thing, you get, bam, $4 profit. So we're going to multiply the 15 by 4. That'll tell us how much you can bring in. And then in addition to that, we know Jay, he sold X number of boxes. And each box should sell, we get $4 in profits. So this should be greater than or equal to the 180 still. And That's nice. Now we have a good expression that we can solve. 15 times 4, bam, 60. Now plus x times 4, we're just going to use the commutative property of multiplication to make that 4x. And this is greater than or equal to good old 180, right here. Now, we're going to subtract 60 from both sides so we can get those x's all by themselves. And then we got 4x is greater than or equal to 120. Bam. Now to solve for x, we're going to divide both sides by 4. And we get x is greater than or equals to
120 divided by
30. That's very good.
Oops.
So now the answer is at least
30 bucks.
30 boxes. At least 30 bucks. But we need to be more specific in this problem because who has to sell 30 boxes? Bam.
Can I write
4J. Because you already sold how many boxes you was going to sell, the 15. By the way, you should work harder next time because you sold half of what Jay did.
Yeah, because look, this is what you can do. You don't have to do anything.
Can I add something
All right,
to it?
well, hold on. So, notice when we divided both sides by 4 right here, those were positive 4s. That's why the sign, the inequality right here, did not flip. Or flip out, however you want to look at it. Billy needed to read 500 minutes this week for his English class. He's going to read 6 days. If he already reads 15 minutes every day, how many additional minutes do he need each day to read? At least 500 minutes. So here's what we got. He's trying to read at least 500 minutes. So in comparison to 500,
105.
right account,
A week.
Billy needs to read at least 500, right? So it could be equals,
He reads one.
but it could be more than the 500. He'd really like that.
500.
So what it says, he's got 6 days to do this in. So we got 6 days. And right now he's already reading
105.
15 minutes every day. So we're going to multiply the 6 by 15, but that's how much he's reading right now. He's not going to have enough. He's not reading enough right now to make his goal. So we know, and that's what it says, how many additional minutes. We're going to need to add some minutes to his 15 every day to get to that 500. So it's 6 times the 15 plus the additional minutes will tell us how many minutes every day he needs to read. So that defines x. All right. Well, from here, we can treat this as a regular equation for math. Now we're going to multiply into the parentheses by 6. Notice we're not multiplying by both sides by 6, just the parentheses there. Which means that we're not worried about changing the sign right account. So we got 90 plus 6x is greater than or equal to good old 500. Right account. Then we're going to subtract 90 from both sides. And then we got this 6x still. And this is greater than or equals to 410. And then to solve for x, we just need to divide both sides by 6. We are dividing by a positive, so our inequality remains greater than or equals to. And we have x is greater than or equals to 6.60, yes, thank you, 68.3
I finished it before you.
repeat.
I finished it before you.
All right, well, that doesn't really answer the question because it says how many additional minutes does he need to read each day to get to 500 minutes of readings?
Billy needs at least 60.
Well,
The next one?
at least 68.3 repeating minutes every day. Kimberly took her 5 nieces and nephews to a hockey game. That doesn't mean it's 5 of each, there's just 5 total there. She wants to buy each niece and nephew and herself a snack. The tickets cost $4 a piece at the door. How much can she spend on each snack if she has 42 bucks with her? Remember to include old Kimberly. All right, so let's look at the number of peoples then. So the number of peoples, we We got,
For all of them to get in.
we got 5 nieces and nephews, and then plus old Kim right here.
Wait, is it 5
So
nieces
there's a
and
total
5
of
nephews?
6 peoples.
Okay.
Alright, so we got 6 peoples. For each of the 6 peoples, we're going to buy a ticket, which costs $4. But in addition to that, we want to spend some money on some good old snackaroos. Snacks, we don't know how much we're going to be able to spend, but we're just going to put some X on that. So X is how much to spend. Spending quiche.
I know a very simpler way where you don't even need X.
Yeah, but it's wrong. All right. Now she has a maximum of $42, which means that it could be equal to the 42, but we definitely can't go over 42. So yeah, it needs to be less than or equal to. Very good. Now what we're going to do is we're going to distribute this 6 right in here. And 6 times 4 is 24, plus 6 times x, bam, 6x. And this is all less than or equals to 42. Now, we're going to subtract 24 from both sides, like these. Then we get 6x is less than or equal to 18. Yeah, that's good. Now, divide both sides by 6. Bam, we get x is less than or equals to 3. So in the context of this problem, in context, we would say Kim can spend at most, because she could spend the full $3, $3 as a rate per person. There it is.
Okay. What
Yeah,
the?
because look, now it equals 0.
What did
And
you
now
do?
it's at most
I don't know.
3%.
Can I do 7?
So while you guys are working on those, I'm just going to point this out, all right? So let's look at a theoretical problem. Something like -2 is, I don't know, greater than -10, right? That's true. Be careful with negatives, by the way, especially when comparing the numbers like this, but that's all 7th grade stuff. So in elementary school, I mean, you guys are well removed from elementary school. You guys went through senior elementary in 7th grade, now you're in junior high because you're in 8th grade. Well, in elementary, they told you guys for some reason that it would be really awesome to add some teeth to this garbage. Right? And they said, well, it's going to eat the one that's the biggest between the two, which was unfortunate because then your elementary teacher, who was really stinky at drawing, like I am, they would draw an alligator like this with a nice little tail up in here. And then they'd give him an eye and they'd say, look, it's an alligator, and it's so awesome because we're in elementary. Well, we're not in elementary anymore, so if I see any of these garbages, just know you're going to be punished. Because this is junior high, so we need to add some stuff to him. So let's go ahead and let's add a nice little shark fin to this guy, right? Maybe some gills up in count. Now he's like a shark alligator, sharkagator. Maybe an alligator shark, an alligark, whatever you want to say, right? But we need to take it a step further up in count. So, because, like I said, this is no longer senior elementary either. So we need to give this guy some wings. Let's go ahead and give him some wings. See how this looks, right? We'll come back. We'll put the fin on, don't worry. But we want some nice bat wings like this, right? There's some bat wings for this guy, and then he's got his old shark fin back here. Well, now it's like a alligator shark bat, an alligark bat, an alligator, a shark, alligator bat. That sounds good. So when we push those together, we got a nice little shalagat. All right. So that's a shalagat. So if you guys are drawing alligators, just expect to be punished. We need wings and a shark fin on that sucker, all right? By the way, you wouldn't want to see one of these in the wild, right? Because, I mean, how do you run away from that? You can't run away from alligators because they're so stinking fast. You can't fly away because it has wings. And if you try to swim, it will still eat you. So If you see one of these, I would at least have a gun with me. So. I don't know if they make Shalagat pepper spray or mace or whatever they call it. Good luck.
Haha. Oh boy. Thank you. So, first thing we do.
Also, I need to get a pen.
You don't have blue. Go with green. So you will combine these like terms first. That was idiot. How do you erase?
Erase your next one down.
This one?
Oh, next one up.
What? This one?
Yep.
There you go, bam.
Okay. And you combine these like.
Next one up for the pen.
There we go.
There you go.
You combine these like terms into 7m minus 8 is greater than or equal to -1. Then we add this -8 to this -1, and you get 7 is greater than or equal to 7m. Pretty simple. Divide by 7. Divide by 7. M is greater than or equal to 1.
Bam. There you go. Excellent work. All right. Let's quickly go. And that is correct, by the way. Let's just check this, though, because on a quiz, like you guys took today, you'd want to check or test. So we'll just check this. Now, this is more of a question mark over here, because right now we're going to replace the m's with the value that we found as old Juan. Right here. And 4 times 1 is 4, minus 8 plus 3 times 1 is 3. This needs to be greater than or equal to -1. Technically, right now we're looking for equality. But 4 minus 8 plus 3, bam, that is -1. So this is where they're equal, which means that we would need to check this portion of it as well. So we need that part to be greater than. So we just need to choose any number greater than 1 and see if it's also true. Something like 10, because 10 is easy. All right? Well, what would that do to us? So let's replace the 1 with a 10. Again, we're looking for truthfulness right here. Then we got 40 minus 8 plus 30. Bam, that gives us a 62. And again, we're looking for greater than this. And 62 is greater than -1, so this one, bam, checks off. All right, I'll do this one real quick for us. So first thing I'm going to do is distribute the -8. I'll do it with the bottom rainbows like this. -8 times 5n gives us a -40n. And then minus -8 times 11 would be -88. And since that's minus a negative, we can change that to a big fat plus sign up and here. And that's less than or equal to. This is technically a -1. It's just a phantom one, which we will now distribute into the parenthesis, which would make us a -7n plus or plus -9 or -9, either way. Oh, I forgot the n for that -40 right here. All right. Well, I'm going to put the n's all on the right side, so I'm going to add 40n to both sides. Now I got my 88 is less than or equal to 33n minus old 9er. Then I will plus 9 on both sides. And then I get a 97 less than or equal to 33n. Yeah, that's right. Good answer, but all right, well, let's just continue then. Divide both sides by old 33. Then we get n And in comparison to this, looks like it's going to be 2 point, someone have that, 993. We'll keep it like that. I know there's more decimal points, right? 2.93 is less than or equal to n. If you wanted to flip this around, so you got the n and then the 2.93 like these, it would just be greater than or equal to. So either one of these works. But again, if you went back up here and checked it, you should get truthfulness. Alright, so on the left side, we have two unlike terms, so we're not going to add or subtract those. We're not really worried about common denominators yet. But we do have this 1/2 that needs to be distributed. So I'm going to distribute that 1/2. Now again, everything on the left side stayed the same. So 73/48 minus 1/6x. This is greater than or equal to. So 1/2 times 7/4. If you use fraction multiplication, right? 1 times 7 is 7. 2 times 4 is 8. And this is the x. Then we're going to add this to 1/2 times 2. 1/2 of 2 is just 1. Bam, there we go. Now for the way that I'm going to do it, I'm going to make this 1 a 1/1. And what I'm going to do is I'm going to find common denominators for all 4 terms, which will allow me then to ignore all the denominators. So I'm going to use a common denominator 48, so 6 times 8. So 1 times 8 as well. So dropping this one, we get 8/48, and that's an x. This 8, we're going to have to multiply by 6, so the 7 by 6 as well. Bam. 42/48 x up in count. And then plus the 1s, I'm going to have to multiply by 48. And we can see that 48 divided by 48 is 1. So yeah, back to this 73/48. That one already has a denominator of 48, so we'll just keep it as a denominator of 48. Now the signs on this, we got a subtraction, and then we got this is greater than or equal to, and we already put a plus there, that's all right. Well, now that we have common denominators for all 4 terms, and it has to be for all 4 terms, we can rewrite this without any denominators. So 73 minus 8x is greater than or equal to 42x plus 48. Oh, that's much easier to look at. So now I'm going to add 8x to both sides. You could subtract 73 if you want, doesn't matter. Adding 8x to both sides, we get 73 greater than or equal to 50x plus 48. So I put the x's on the right side, which means this 48 is on the wrong side of the inequality. So minus 48. And we have 50x, and this is less than or equal to, what the heck is that, 5, 7, 6, 2, 25. And then divide both sides by old 50. And divide by 50 up and count. And then we get x. And this is less than or equal to 1/2. Or 0.5 if you want the decimal. So we could have written it as x is less than or equal to 1/2 as well. Or 1/2 is greater than or equal to x. And it's on the right. Alright, we did this for the other period. I'm going to do it for this period though. Because you guys need to know this because, well, see, in 6th grade and below you guys were in elementary. 7th grade you guys are in senior elementary even though you come to the junior high. It's not until you're in 8th grade that you're really a junior high student. So,
Really?
as it turns out.
Am I old school?
Well, some of you guys are still stuck in the senior elementary behavior, which is why you're talking while I am. It's not very, junior high-like of you. I suppose elementary teachers like that. It's like everyone just gives each other a hug and calls it a day. But not here in junior high. So just to demonstrate this stuff, and this will remind you guys of good old elementary. Let's compare a couple numbers like, I don't know, -2 and -10 right count. So before in elementary they'd say, well, hey, look, -2 is worth more, so it's going to be eating the -2 right count.
The alligator.
And yeah, because they were in elementary, they like drawing pictures, and
The alligator.
they thought it was great.
The bigger
No,
food.
it's a shallot.
Thought it was great to give some teeth.
Can I draw like a little?
And then if they got really ambitious, as elementary teachers do,
Yeah.
they would throw on some eyeballs and some feet, right account, with a tail.
Pretty good artist.
You guys remember this?
The shallot. That's what it's called. See?
Then they would give it an eyeball, right account. Maybe he's really mad for some reason.
I remember those.
But
You
he
gotta
doesn't
stay
have it
figuring
that way.
this.
All right. If for some reason you guys are gonna call this an alligator, just know that I can't have any of it because we're in junior high. Okay? I don't want to see no stupid alligators. Here's what you got to do. All right? We just got to add some stuff to this guy. So let's go ahead and we're gonna put on a nice shark fin on this guy. Give him some gills up and count. See, now he's like a shark alligator, or an alligator shark, an alligark, or a sharkagator, right? Yeah. But this is very, very much 7th grade like. We gotta step it up in here. So we need to add a little bit more than just shark fins to this guy. We're gonna give him some wings up in here.
See, I told you.
Some nice.
Shallot.
It's not my best drawing, but anyways, he's got a nice shark fin right here. Now he's got an alligator, a shark, and a bat, an alligarcat.
It's a shallot. It's a bark.
Maybe a shark, alligator, bat would work. Yeah, a shallowgat. Bam. There he is.
Now can we do a fishing method?
I have to warn you guys. Many of those animal activist people have been killed by these. It's unfortunate because, right, if you're on land, you can't run away from them because alligators are fast.
And if you're on water, you fly.
If you're on water, they swim and just eat
Or
you
they'll
up.
fly.
Can you draw?
But if you have somehow you can fly, bam, it just eats you up, man. He's gonna fly and he's gonna eat you up, okay?
But we can't draw.
It's a good color for you to use. Good luck.
Okay. I'll do the X's on this side and the numbers on this side. Just saying. Okay. So, first of all, I'm just going to hurry and add these two together. So, I'll just do 6x 3. Okay. Now, I'm going to add the 3 on this side and add the 3 on this side. Wait, wouldn't that turn? Okay. So this would be 0, and this would be like this.
There's too much talking over there.
And then I divide 6 on both sides. X is greater than. What's 0 divided by 6?
0.
Sorry. Oh, yeah.
No, it's 0.
No, it's 0.
Alright, okay.
I'm pretty sure it is.
I got x equals negative.
Alright, excellent work. Thank you. When we check, we first have to check for two, just so you guys know, we have to check for two things. The first thing we need to check is for equality, meaning that if we replace x, the x's with 0, we should get what it equals, because we solved it exactly like an equality. So, let's go and see what that would be. So it would be x is 0,
No, it's x is anything bigger
then minus 3 plus 5 times 0. And this should equal negative 3, right? Because I'm using the original inequality to check for equality. So 0 minus 3 plus 5 times 0 is negative 3. Negative 3 does equal negative 3. That's true. So right there, that just helps us to know that we solved the equation correctly. Now let's check the inequality to make sure that it's eating the right thing, the shallowgat, if you will. So to do this, we just need to test any number that's greater than 0, because we checked for equality. And if we find that it's false, then we just know we need to change the way that the shallowgat is eating. So what's a number bigger than 0 that you guys want to test?
negative
Got it, 1. All right. So I'm going to replace all the x's with a Juan. So I got 1 minus a 3 plus a 5 times a Juan. This should be greater than -3. If it's not greater than -3, then we need to go back and fix the inequality, which rhymes. All right. Well, 1 minus 3 plus 5 times 1, that's 5. It should be greater than -3. There's a question mark. 1 minus 3 plus 5, bam! Oh, what is that? Let me check. 6. Hold on a second. That's good. That's 3. 3 is greater than -3. That's true as well. Therefore, we know now that our answer is correct. Good luck.
So we'll have
You mind explaining while you do it?
sure. Wait, so we're just did that, and then I'm gonna add 10n, right? Or would you go like that? I don't know. I'm gonna have 80 plus 12. I messed up on something. Can I get some help?
Did he mess up on something?
Yeah, he has to combine like terms.
Does he have to combine like terms?
Yes, he does.
No!
Oh, right.
Not yet. I mean, he can if he wants, but it's not really necessary that you do. So let's continue this, right? Let's combine those n's on the right side. -10n plus 10n, bam, 0n, like these. All right.
There's no end.
Now we're going to add 24 to both sides, like these. Oh, I guess we can combine these like terms. That's a -68. But then we're going to add 24 to this, and we get -44 is greater than or equal to 0n. All right. Now what we have is -44 is greater than or equal to 0n. What value of n can we plug in to make this a true statement? 1. Let's try 1. 0 times 1 is? 0. Is -44 greater than or equal to 0? That's false. Is it? Well, so what's another value? Maybe
30.
like 3,000, right? Well, what's 0 times 3,000? 0. Well, is -44 greater than or equal to 0? False.
False, so it's false.
So, as it turns out, for this type of problem,
Has to be negative.
what values can we plug into n to get a true statement?
300.
No
I knew it.
solutions.
There's no solution.
By the way, just in case you guys see this on the homework, what would we do if that -44 was a positive 44 right account?
It would be no solution.
It would be all real solutions.
What? Yay.
All right, number 12, right account. So right there, I'm going to treat that as a -2 over a Juan. The reason I'm going to do that is so that if I find common denominators, I can just get rid of them altogether. So the denominator I'm going to use is old 9er, so I'm going to multiply the 1 and the -2 by 9, giving me a -18 over 9er, A. And then the 3 I'm going to multiply by 3 and the 5 by 3 as well. So I'm going to add this to 15 over 9, A. By the way, this can help us combine like terms anyway. So this is less than or equal to -8/9. We already had the 9 denominator. So now I can rewrite this without any denominators, which would be really nice. So I got -18a plus 15a. And this is less than or equal to negative 8. See how I got rid of the denominators? So awesome. Now I'm going to combine the a's. Negative 18a plus 15a is a negative 3a. This is less than or equal to negative 8. And from right account, I can divide both sides by negative 3, right? That's pretty sweet.
Decimal.
Then I've got a is less than or equal to 8/3. False.
No.
It is not less than or equal to 8/3. It's greater than. Okay? We had to flip the inequality because we divided by a negative on both sides.